This lesson is about operations with polynomials, where you are able to add, subtract, multiply, and divide them. Let's consider these two functions, f of x and g of x. It doesn't really matter what the letters are, of course, just that you can do things with them. Okay, so I'm going to say A, let's add them. So we would use this notation, or you can see that notation that tells you, oops, I said I would add them, let's add them. So this one plus this one, so this function plus this function means that part plus that part. So that means it would be negative 3x plus 7 plus 2x squared minus x. Now in reality, they're first in parentheses, but there is nothing multiplying to either of them to change that. So adding this and adding that, we can write it without the parentheses. And then the like terms are added together. Well, there is only one squared term, and that's the highest degree, so I will put that one first. And we have two of them with x terms. So negative 3x minus x is negative 4x, and then plus 7. So when adding them, that is the answer you get. Having added them, now let's subtract them. We will do the function of x subtract function g, function f, function g. Now, we could also do it the other way, but we're going to do it this one. We're going to do negative 3x plus 7 subtract 2x squared minus x. So this is negative 3x plus 7 subtract 2x squared minus x. So what I'm going to do is, this one here, there's nothing multiplying to it, so I can keep it as negative 3x plus 7. And I'm subtracting 2x squared minus x. I just made a mistake. On purpose, I made a mistake. When you have a negative outside of parentheses, that means you are required to distribute it inside. So a negative like this, negative 2x squared minus x, is actually the same thing as, and in reality is, this. So it's negative 1 times this. If this had been something like a negative 3, you would have known to multiply negative 3 times this and negative 3 times that one. When you don't see anything but the negative, sometimes people get confused about it or just don't even think about it. So you have to force your mind to think about the fact that there's a 1 there, so it's negative 1 times this, which makes negative 2x squared, and it's negative 1 times negative x, which makes, with two negatives, it means this is positive. Now, I am correct. After that, it's the same thing that I did here, or same method where I combine any like terms. Only one of them has a square, so it's negative 2x squared. Two of them have x's, and so it's negative 3x plus x. Now that's negative 2x. And there's only one constant, so that is the result of subtracting them. So there's a slight difference between them, but it's enough to make them false or correct. So this is what happens when you subtract them. And then let's multiply them. So I am going to subtract, now we will multiply. So we will do function of x times the function g. X, function g of x. Try and find the best way to say it. So we're going to do negative 3x plus 7 times 2x squared minus x. This just becomes the FOIL method, or think of it as multiplying with any binomials. So it'll be this one times that one. So that's negative 6x cubed, then times this one, so we get a positive 3x squared. Then multiplying here, we get a positive 14x squared. And then this 7 also multiplies to that one to make minus or negative 7x. I'm going to check my negatives. Negative and or a negative and a positive here makes a negative, negative 6, and it's x cubed. Here I'm going to get a positive, and the 3 doesn't change, but the x's do. Then here I'm going to get a positive 14, and x squared, and here I'm going to get a negative, positive, negative. So it looks to me like I have done my negatives correctly. Well, I look at the terms and two of them are alike, so I can combine them, but not the others. So I have negative 6x cubed plus 17x squared minus 7x. That is the result of multiplying them. Dividing them is actually a different lesson, so we won't go into that right now. Dividing polynomials can be done with long division or with synthetic division, but that's for a different lesson. So let's now look at composition of functions. Part 2 of this. Composition of functions. Composition, compose, that word compose, you're making something. What you're actually making is a new function by combining, not through the normal operations, but by putting one function inside another function. So let's take the same two functions, f of x equals negative 3x plus 7, and g of x equals 2x squared minus x. Okay, those are the same ones that we had. The notation that's used is two possible things. It's this function and then this function inside of it. So this function gx as that x. Or it can be written as function x and then this big O. It sort of looks like an O, but it's really not. And actually, we often do it just like this, without even the x's. So it looks like fog in this case, but if it was, say, H and L, or M and R, right, it doesn't really mean anything. It's that this is not a zero, it's not an O, it's a math symbol telling you to compose the functions. And it could be the other way around. It could be that we did g f x, or we could do g o f, and then that would change it. This one's telling me to take this and put it inside here. This one's telling me to take this one and put it inside here. We're going to do both of them. Okay? So first, let us do f g x. And that means I'm going to take the function of x, which is this, negative 3x plus 7. Instead, I am now going to do this, which is negative 3, and in place of that x, I'm going to put the entire gx, g of x, 2x squared minus x, and then plus 7. So that's negative 3x plus 7. I just replace the x with what this function is. And at that point, now all I do is I simply calculate it out, all on this side here. Negative 6x squared, and negative is a positive, 3x plus 7. That's it. There's nothing more to do with that one. And I could have written that as f and that symbol. And that's the result of putting g into f. Now let's do it the other way. Let's do g with comprised of or composed of f. So g composed of f. That's probably the best way to say it. G composed of f, g composed of f. So f goes inside g. So g of x is equal to 2x squared minus x. And so now g function of x is equal to 2. And I need to take what the function of x is and put it inside to replace the x. And then so this gets replaced minus, and there's another one, minus 3x plus 7. So that also gets replaced. Two of them can be replaced. Now, that means, and I'm about to make a mistake here. So if I square 3, I get a 9. If I square x, I get x squared. Okay? And if I square 7, I get 49. Minus 3x, and then that minus, remember, hits the other thing too. So I did not make a mistake with the negatives, but I made a mistake here on purpose because it's a very common mistake and I don't want anybody else to make it. It's that what I'm showing here right now, I purposely left a space to write something in, so you can sort of guess what it is that's going on. But what I'm showing here is as if somebody just distributed the exponent to the 2 to this and 2 to this and the 2 to that. It looks like that sometimes, but that's not really what you're supposed to do. Exponents can't be distributed like that. Instead, remember, and I'll use the space over here, remember what this means. 7 squared, you know that's 49, but the reason it is because you are multiplying this number 2 times. And that's the point. It's this thing multiplied to itself. So what we did not do here is this whole thing multiplied to itself. That was supposed to be 3x plus 7 times 3x plus 7. So 3x times 3x is 9x squared. That's this one. Then here we get 21x. Here I get another 21x, and here I get plus 49. That 42x in the middle, you don't get if you just distribute the exponent. You get the other ones, but that's not enough. So now I'm going to write in here plus 42x. Because that was supposed to be there. And now I did it correctly, because now I did 3x plus 7 times 3x plus 7. Watch out for that, because it's a common error since people get caught up in what they're doing, and they sometimes rush a little too much and don't realize that they're forgetting to multiply it correctly in order to get the right things here. Okay. Now I will do the multiplying of the 2, so that makes that 18x squared plus 84x plus 98 minus the 3x minus 7. And now we combine any like terms. And only one of them is a square. And then these two, ooh, I forgot something, I just realized. Did I forget something? I did forget something. Okay, let's come back for a moment and let's fix that. I wrote 3x plus 7. I forgot that there was a negative here. So I'm going to continue this one as if f of x is equal to positive 3x plus 7. So for positive 3x plus 7, this is right. If it was a negative, it would change things, because I would now have not a problem with this 9, but I would have ended up here with negative 21 and a negative 21. It would have been negative 84. I wanted to throw more negatives in here, but we'll live without it. If we treat it this way, the way that I was doing it, if it was 3x plus 7, positive 3x, then all of this is still correct, so I'm going to continue it now. All right, so 84 and minus 3 of them makes plus 81 of them, and 98 of them, take away 7 of them, is 91 of those. And I think I now have all the negatives right, with that one being a positive. It's all positives in here, the negative and the negative to here, and then subtracting it from that in this case, and this is my answer here. That's how you compose functions, and that's an important one to do, especially because recognizing that you may have this to deal with. So make sure you're careful to do that one correctly in any of these composition functions. So the lesson for operations with polynomials is first that you can add, subtract, multiply, and divide them. And dividing with a separate lesson now, but adding them is just adding the like terms. Subtracting them is subtracting one from the other, so it's changing the signs and then combining like terms. And multiplying them is multiplying each part of this binomial to each part of that binomial. And the second part of operations with polynomials is that you can compose functions by putting one inside the other. And recognizing this notation is important, that this is a function f composed of, or including inside it, function g of x. And this one is g composed of f, with f inside it. That's the same thing as what this symbolism means too. So down here we did the function f composed of the function g, and so g's literally just went in place of the x. And then again, multiplied and combined like terms, just like normal with polynomials. And then here we were combining, putting f of x, but the new f of x with a positive 3x, in both of these places in g of x. And here and here, then squaring that correctly. And that's an important part of this one too, so that we get this as the result of g of x composed of f of x. So it's a brand new function. Hopefully that helps to understand the parts of this section on operations with polynomials.